Back onto this Ultronics kit that I built from Silicon Chip Magazine, Colour TV pattern generator. And the reason is, after I fixed this originally, I had to fix a little RGB to composite video conversion chip in there, which was faulty. Someone had previously built this thing, I did a video on it. But anyway, fiddling with that actually made me realise that these could have the potential to have an RGB output on them. And a guy on Facebook actually sent me an old Philips KT3 chassis that I agreed to have a look at for him. And it had been modified for an arcade game, came with this plug-in module to replace the original colour decoder. And this was made for the JAMMA board, the JAMMA I think it is, which is the computer game boards used in arcade machines. And all the monitors have a standard input RGB and sync. All the boards, I think they may also have composite and other things coming out of those boards, but the boards are made to be plug and play basically, with a big edge connector on them, similar to what you see here, but double-sided I think, like a computer edge connector. And when you plug them into a cabinet, it automatically plugs all your joystick switches, coin slots, power, etc. into any card, so you can just change your game over straight away, though you might have to add buttons, remove buttons and things like that. But normally the power, the video monitor and all the rest are pretty much standard. So he sent me this thing, and I actually hacked into this unit and soldered some wires right across. I basically disconnected that little surface mount chip I played with before, and a link that was the sync signal, and just pulled the sync out, pulled the RGB out, ended up disconnecting the resistors that pull it down to ground and stuff in this thing, and set the levels. And it turned out the RGB was a bit too strong, so I had to put some resistors to drop that a bit. I didn't worry about the sync, that seemed to work fine, but I found out later that was actually 5 volts peak to peak, and probably the RGB, since it's all TTL or CMOS type versions of TTL chips in there. So, and that worked fine for testing this set. It turned out it looks like it's a sync separator chip, and it's faulty. It's got vertical issues, had a couple other problems I had to fix. There'll probably be a video coming out on that later. But then I actually, while I was fiddling around with that, since it was a Philips KT3, I remembered I had what I thought was a KL9 Philips here. Turned out to be a KT3A3 chassis, and it had Scart on the back. I knew that much. I'd never plugged it in. The cord was cut off. Came from the e-waste pile for a couple of dollars, and I thought I'd try that out. And that's when I decided I probably should set this thing up properly. And what I found out is I had to drop the sync level as well, because the 5 volt peak to peak, just the Philips couldn't handle that. And the other thing I found, because being an old TV, on the Scart, if you want it to go to RGB, there's no menu or anything. You've actually got to put a 5 volt line out into one of the pins, and I'll tell you the number after. And so I added a socket for that as well. So I've got another switch on the front here. This one, a 4-pole double throw toggle switch, just one you can buy at JCar. And I've now got a bunch of sockets on the back. I've actually labelled these because I forgot what they are. That's just the RF. Wanted about 15 volts AC. That was the original RF modulator. Had video out and audio in for the modulator, because there's no audio generator in it. So I've added a red, green and blue socket, which JCar luckily have those colours and make it a lot easier. Use the yellow one for sync. And then I've got I think it's around 3 volt, that's right, I thought it was 5 volt. Comes off the 5 volt regulator in here, but you put a resistor in there, 180 ohm or something I think it was, just to lower it down. I think the Scart connector anywhere from like 1 to 3 volts or something on that line tells it to go into RGB mode, otherwise it just sits there in composite. And I basically found an old alarm. These are common power packs for alarm systems. I had that lying around, puts out 15 volts AC, so it needed something a bit more than 12 volts I think. So I've wired a plug onto the end of that, a bit messy because I couldn't fit the cable into the actual thing, but so I've added that to it just to make it easier. I almost thought about fitting a transformer in here, but it was not really enough room to do it easily. So I'll have a look inside this thing, because it's probably not a lot of these still around, and the problem with this kit is it had a microprocessor in it, which is a programmable one I think, so it probably could still be obtained and people could still make this one. But it may not be a lot of use because there's probably not a lot of them around here, but at least it is a kit one, so there's a possibility of people still making these, because it's hard to find a pattern generator with RGB out unless it's like a really expensive professional one, and a lot of those are American standard or something if you look on eBay or somewhere, and no good in Australia for me. So all I had to do, this is actually an aluminium front, so I had to remove that so I didn't get aluminium everywhere, but just drilled another hole above the colour grayscale switch. In line with that, obviously mounted these extra 5 sockets on the back, and what I had to do is simply there's some resistors here. We've got that, what is that IC? It's a 74HCO4, this one down the bottom corner here. So that's like the right front of the board. That's where your RGB signal comes out. There's these 2K resistors mounted on the board, or they were originally. I've now got them standing up with one end going into the board, and then a bunch of, I think they're 330 ohm. And then above those 330 ohm, they've conveniently, because they had to skip over a track on the other side of the board, put the sync line. So it's all nice and easy to do. I just upended those resistors, pulled out the link for the sync, ran them up to the center part of the switch here. So the signal coming out of that IC goes to one side of the switch. Or does that go to the middle? It goes, oh no, it goes to the middle of the switch, of course. So there's 3 contacts there, and the brown wire here is the sync coming out of that. I don't know if it came out of that chip. I think it came out of some of these other chips. That goes up to the middle of the 4th set of contacts on the switch. And then on the bottom ones I used, so that's when the switch is up and not on basically, it just basically goes back down these little, I just used a bit of twisted pairs out of an old network cable. They go straight back into those 2K resistors, and the sync line goes back into the little AD722 chip there. So basically in that mode with the switches up, it just functions as it did before, has composite output and stuff. And I thought probably best to actually disconnect, because this has resistors to alter the levels, and plus you've got that other chip putting a load on it probably, so I thought I'd disconnect that completely. It may be possible to just actually tap into these and run all the rest of the pattern generator as normal. I didn't actually try that. I thought I'd actually switch it. When the switch is down, we go to all the up contacts, the middle ones connect to that, and I basically end up putting some 470 ohm resistors on each of the RGB lines to drop the level to about the right level. It probably could be tweaked a little bit more, but it's pretty close to what you want for video levels. And I've got a 220 ohm on the sync line, because like I said, the Philips TV that I got, when I put like 5 volt peak to peak into it, just directly out of that sync line there that goes into the other chip, it did not like it at all. I've got some sort of weird little dots on the screen with sort of streaks or lines or something, and it took me a little while to work out that, yeah, it must be the sync was too big. I forget what, I think with that resistor and these on the 470 ohm on the video, they all come out more around the sort of 1 volt peak to peak, or a bit less, which is where they should be. Now the other mod I did, all these just have all the ground soldered together here, off the original, what was that, audio in socket. So, and then I actually use shielded cables with the other end just connected to the resistors, no grounding at that end. Same with the sync line. I thought it's probably best just to shield them since they're quite long. Don't know if it really needs that. And they did use shielded cables on a couple of these, what's that, the colour grayscale switch, so I thought it might be best with all these digital chips. And yeah, this 5 volt socket was a little bit of an afterthought, but I patched that in. All I did is the output of the 7805 regulator, the third one across here, on the right side. I've got a 180 ohm resistor from the output pin. I just soldered it straight to the pin rather than going anywhere under the board or anything, and just straight up to the middle pin of the socket. So this socket's got earth on one side, 5 volt on the other, or 5 volt drop down. Once you plug it into the TV, it definitely drops right down. It'll probably be 5 volt open circuit, of course. The resistor isn't going to drop with no current going through it. And yeah, once you plug it in the TV, I think it came out in around 2.5 volts or something, but that was enough for the TV to be happy to switch itself to RGB. So it's a useful little mod you can do. I'll probably get the circuit diagram and actually, I could probably show it to you now, but yeah, it's this. That's how all these buffer or inverter looking type triangle parts of that 74HCO4, and each pair of buffers or whatever they are is joined together. You've got their 2K resistors, which is what I've pulled out where these chips join the 2K resistor. I've lifted that end off the board. The 2K's then joined to this 330 ohm to ground and into the AD722 chip. So when we're just in normal mode, we just switch through, it looks exactly the same as this circuit. And when I switch it to the back sockets, it comes out of each of these buffer chips via a different value resistor, which I had 470 ohms, to each socket on the back. And the sync line was, oh there it is, comes in on pin 16 there, but there is a convenient link there, so that goes back into this other, into the micro by the look of it, and somewhere else. So you just break in where there's a link there, and again drop it by a 220 ohm resistor, and that goes to the back socket. But I might actually Photoshop this thing a bit and see if I can just add the switch in, just to give people an actual circuit of what I've done, in case anyone's interested, if anyone can even manage to build one of these things anymore. But this has made this super handy now, so I can plug into RGB Scart, I can plug into a JAMMA type monitor and test anything like that. If I get a PVM or anything, I can test the RGB inputs on it, any of that sort of stuff. I've got a nice little source of RGB signals now, because I didn't really have anything back in the day when I was doing TV repairs. I can't think of any time I ever had to test RGB, because the average consumer just wasn't interested in it. And any more professional monitors I fixed, I think often you just plug something into each channel and just test it, and that was enough normally. I don't think I ever had a reason to have an RGB pattern generator before. But with some of this retro gaming stuff and everything, it's quite handy to have. So I'll probably just show a modified version of that circuit. Hopefully Silicon Chip don't get upset about that. I guess, well, that's not even the whole circuit of this thing, I don't think. Looks like it goes, maybe there is more. Oh, that's the port. That's just, I thought that was connecting to something else. So that sync line comes out of the microprocessor, but it also goes to that port that you can program the thing or whatever with. But yeah, so I don't know, whoever designed this obviously got it to the RGB stage pretty much, but never thought of adding the sockets, or if they thought of it, they thought there was no use for it, because back then there wasn't really any call. But for a price of another switch and a few sockets, you could easily modify this thing. So kind of crazy they didn't add that as at least an option for people to do. Sort of like, if here's the kit, and if you want to modify it a bit, here's how we do it. So I might have a look at my older pattern generator one of these days as well, because that's a more simple one, just discrete components. The patterns aren't quite as symmetrical or spread out properly. The bars and stuff on it aren't quite as good as they should be. This one does put out nice proper patterns with all the bars the same width and all that sort of thing. The other one, I think it's just really the color bars, the border on it, the black and white part of the grayscale basically are wider than the other parts, or something silly like that. It was a bit of a compromise, but it did the job for normal. All the other geometrical things, the crosshatch and checkerboard and stuff, are all right on it, and the dots. So it was fine for setting up geometry, but it wasn't quite as good a unit as this one. But yeah, this should be a handy little unit now. I can just plug in an RCA lead. What I did find is you can actually use one of these standard component SCART leads, which I might add to this video. I'll do a separate one on. This one's got mod RGB on it because I've modified it. You don't have to do anything with these. These are the same for either RGB signals or component signals, the R-Y, B-Y, and luminance, or whatever it is, the G one. So they're the same, but what you do have is a couple of spare plugs here if you don't want to do audio, you just want to test the video side. So you've got an audio, these were audio out originally. So I just basically swapped those over. One of those is now, I think the white one was the 5 volt and the black the sync. I can't remember now, I should have really labelled at least one of those. I can soon test that out with a multimeter. But you can basically just undo these things. I think even the sort of cheapo leads, they're all actually, they're not moulded plugs on the SCART. If I can get that to come open, they're always a bit of, I think you grab them here is where the cable is, that's it. I've hardly touched SCART in my life, so I didn't have a lot to do with it. But you take those, so you can see the blue, green and red there, and I think that's a ground. Each one's got shielding on it, I think, so it's a decent quality cable. Some of the cheaper cables, they don't even do that. And I think that those two pins there, which are, what are they? 7, 6, oh, what, 5? God, it's hard to read the numbers on this. They're all over the place for some reason. Where are we? There, one should be even, one should be odd, but oh yeah, 7, 9, 11, so that's 5. Oh, that's 3. It looks like an 8. No wonder I can't really see what I'm doing. So it must be 1 and 3, I think, with the audio out or in, depending on which way this lead was used. I think the separate ones for audio in and out, and I disconnected those two cables. I think that's the white one's one of them. That's now going to pin 11. That might have been this, no, 14. God, that's hard to see. What's the last one you've got? Would have helped if they printed the numbers. Oh, maybe it's 16. Oh, that's 20, 18, 16, 14. So the numbers on that side. Oh, is it? 2, 4, 6, 8, 10, 12, 14. So it's 16, third one in. Pin 16, and it must be this other one here, which is pin 20. Might have been 16. One of them is the composite input, which is also the sync. So you can just put a composite thing out. I think most of these will decode. They'll get the sync out of the composite if it's just composite, because I've got a PlayStation lead off eBay and that just puts composite up that pin. Because I found that out because it was just in composite mode, and I found that old TV I had to put the 5V, which might be that pin 20. Yeah, I think that's the only other pin left. Yeah, that yellow wire was just confusing me a bit, but that's because I had to extend that pin because it wouldn't fit, because they were down the other end, the audio ones, and it wouldn't reach that far. The other one's pretty well stretched tight just to make it. So I took the audio leads. Looks like I put one on, what did I say it was, 16 and 20. One is for 5V switching, the other one is the sync line. So you can either put composite up the sync line or just sync out of this pattern generator. And just like that, you've converted. These seem to be common all over the place. You can pick them up secondhand very commonly. These, about the most common Scart cable when I went looking for a few at the tip shops and stuff, was this one. Now I've got to remember how that goes back in. That's it. There's a little slot there the metal bit has to sit into, or the plastic bit that's clipped in the metal bit. And you can get these component leads quite common, and they're much more use than a composite lead or whatever anyway, because they've already got your RGB all set up. But if you wanted audio, yeah, you'd actually have to add some extra wires. But that's a simple way to mod that over. And this is the PlayStation cable I got off PS1, that is. I got this off eBay for 10 bucks or something. I thought might as well just order one, especially with that oddball plug they have. But what I had to do, actually I forget, well, there's two wires here. I had to add in a couple of wires, one for the 5V definitely. I can't remember what the second one was for, I'll have to look. But these have RGB and composite running in parallel, but they don't have a 5V switching line. There may be somewhere on this coming out of the PlayStation, I don't know for sure. I doubt it would be putting out 5V anywhere. But what I actually did was, I know what the other one was. It was ground, that's right, because you have to have a ground connection. Just putting a 5V line from this unit to the PS1 did nothing, of course. I didn't click straight away, and then I realised, of course, it doesn't have a ground reference, so that voltage might as well be nothing. So I added an earth wire as well, so just so that when I plug into this socket here, I can actually use this while running plugging the PlayStation lead in the PlayStation. As long as I put 5V and ground up this from any source, and this is as good as any, I can actually get the TV to switch to RGB, and it was a noticeably better picture. But of course what I found is my old PlayStation 1 that hasn't been used in years wouldn't even read a disc, so I've had to order a new laser for that one. So that'll be another repair video, whether it'll fix it or not. It's just one of those, the later little compact PS1s that I scored from somewhere because someone didn't come and pick it up after I modded it or something. But yeah, the damn thing wouldn't even fire up, but I can at least get the video out of it on the startup where it's asking to play a CD or whatever. If I put 5V and ground up there, I should have put a plug on here so I can plug it in there, because I'll have to pull it apart probably, or find molding meter through to the right pins. I guess one interesting thing will be if it's pin, I know it's now pin 20 or 16, I can quickly find which one is the 5V. Well, that's 16 straight away. And that's the one next to it, so that's probably the ground. Yeah, every alternate one there, so that's the RGBs around there somewhere. So that's the ground. Just bend that one. So it's pin 16 is the 5 volt. Must be 20, I think it's the composite slash sync line. But I might have to do that on another video, would probably make more sense. Show how exactly what pin numbers to do. And yeah, this is very handy to have now, so I can test RGB inputs and all the rest. But anyway, thanks for watching.